Hey everybody, welcome to Lab 10. This is Sean. Again in this lab, I'm going to continue showing how to do some journalistic data analysis in R. Today's lab is all about a deep dive into cleaning some messy data. Cleaning data, making sure that it is prepared and ready for analysis is one of the least sexy things about data journalism, but it's also one of the most important things. I spend more time cleaning and verifying and fixing problems with data uh, that prevent me from getting to the sort of more fun analysis part than I do actually doing the analysis. So learning this skill, being able to identify problems is pretty essential. In the Quartz Bad Data Guide that you read for this week's class, you'll see a lot of examples, common things where uh, data sets you're working with can go wrong. Some of those things are fixable by us, some of them are not. But in this lab, I'm going to show you some of them, and some of them you've already done before. So this lab works the same way as previous labs. Um, you're going to follow along the code that I run. Sometimes you'll see a task word, and that's where I want you to do something. And after you finish working through all the tasks, you're going to save this, knit it, and export it, put it on your Git repo, and then post that to Elms. So here's some cheat sheets. One new one that would be worth looking at is we're going to work pretty extensively with a package called Stringer, uh, which, because R loves puns, the little hex icon is a violin, strings. It's all about working with and modifying and detecting um, data that's stored as strings or collections of characters. Okay, so you're gonna set up your lab as usual, and we're gonna load three packages today. So the first thing is the tidyverse, which we use for analysis, but we also use for reading in data, and a lot of cleaning functions are built into that. One of the things that's built in is the stringer package. Janitor, which we've used a lot to clean up column names. I'm going to show you one new function today. And again, we're going to use rvest just for pulling in some data. So go ahead and load those there. So you're loading janitor, tidyverse, and rvest. Okay, so the first thing is we're going to get in some dirty data. So the code for this the data set we're going to bring in this week is actually one we learned in Lab 8 when we wrote some data to scrape the drugabuse.gov website to get state death rates of opioids. So I'll just show you that here. So there's this table on the page. This is an HTML table with 2017 opioid-involved overdose rates by state. So it's going to come in pretty messy, and we'll look at that. So refer to Lab 8 if you want all of the details here, but essentially this is we're reading in the HTML page, we're stripping out a table, and we're converting it to something that R can make use of. So when I pull that in, pop it up here, we get this this data set. I'll just pop this out so we can look at it. Side by side with the text here. So let's go ahead and take a look at this table. This is how it came in. So first, the column names are like super complicated. Just all these like periods and capital letters. It's kind of a mess. Um, it's got in the middle of this like blank row, just event A's and row 37 there. It's also got this row here, not included, did not meet inclusion criteria. That's sort of like a header from the middle of this table. Not particularly useful. Um, It's also, instead of like having missing values like Alabama, Arkansas, Delaware, some other states were not included. Instead of being like a proper NA, which is something that, is a format for a missing value in R, the people who put this data table together used an asterisk character. So that's kind of a mess. So we want to fix these problems. Um, because when we don't, if we fail to do this, it can create problems for us down the road. Can hold up the analysis, and we'll see some examples of that. So one thing about process here too, as we work, I'm basically going to build a single function and then keep adding to it every time we want to do some additional data cleaning. And this is generally how I'll structure things in my document. I'll load in the data up top. I'll do some cleaning to it. After it's cleaned, I'll then do some analysis. And so if I want to do some additional cleaning, I'll just go up to the top and update my script. This is always how we want to do data cleaning. You know, let's say we had this table as a spreadsheet. One way we could do this would be to like open in Excel, uh, strip out the columns, um, rename the columns. Um, we generally don't want to do that, and the reason for that is that writing scripts in a Markdown document allows us to preserve a documentary record of what we've been doing, our cleaning function. So that if we make some mistake down the road, we can just load the data again, tweak our cleaning function, and then go from there. This is a much more transparent, reproducible process, less likely to lead to errors, less likely if you have to reproduce work to go back and start all over again. Okay, so we're going to take all of these things piece by piece, all the errors we identified, and clean those up. So I'm creating a new object called opioid scrape working, which is basically just a copy of the opioid scrape table. First thing I'm doing is cleaning up the names. So this is the clean names function from janitor, and you'll notice it separates them with spaces. This is still a little long and unwieldy, but it's a little bit better than before. Everything's lowercase. Starting to get a little bit cleaner. Okay. The next thing we're going to attack is this totally empty row. It's just 3 NAs all the way across line 37. If we were in Excel, we could just delete this, but in R, we actually have to add to our function to do that. So I'm going to use something that's part of the janitor package called remove empty rows. So just, again, opioid scrape working, making a copy of opioid scrape, cleaning the names, and then I'm removing empty rows. Just pay attention here. This has 53 rows. When I run this, now it's got 52. So what's missing? That NA row that was in the middle. Okay. We still have this annoying row, which is in the middle of our state column. Instead of a state here, we've got not included, did not meet inclusion criteria. Not particularly helpful. So we want to filter that out. So I'm going to show you one way of doing it, and I'll also show you like a slightly alternate way of doing it. So what I'm doing here is after I take my opioid scrape original table, clean up the names, remove the empty row, now I'm filtering, and I'm using the string detect function that's part of stringer. So string detect says, look in the column called state, look for the words not included. Okay. And the exclamation point means the opposite of that. So when I run this, now it's gone. Just as a reminder on what the exclamation point does, it means not. If I remove that and run this, it now only has one row. It filtered just for that one. So the exclamation point means the opposite of that. One way that you could also do it is by filtering and just targeting the specific row number. So I'm just going to run this again, but only up to remove empty rows. So this thing is still there. Okay. Notice that it is in row number 36. So instead, I could do, I'll just comment this out and run this. And now it's gone again. So just an alternate way of doing it. What it said was find row number 36, filter everything except for does not equal number 36. I only point this out by way of saying that there are, generally speaking, when you're doing data cleaning or other kinds of analysis, often many, many ways of doing the same thing. And it's really just up to you to kind of be creative and, figure out what would work best. I'm only scratching the surface here of what a lot of these packages can do. So there are other things that you'll need to know when you do data cleaning. And probably the best way to find things is by going out and Googling, how do I remove something based on a value in a column, or trying to put into words whatever problem you're having. Okay, so the next problem that we've encountered is that about half of the states have this asterisk here. This is a missing value, just wasn't enough good evidence to include it in the study, so it was left out. We want to replace those and make them proper NAs, actually stored as what R recognizes as an NA or a missing value. Right now it's not, it's just this asterisk. So if we think through how to do this, if you were trying to search how to do this, you might search replace a value in R with an NA. And if you search for that, you'll find that the dplyr, which is part of the tidyverse, has a really nice function called NAIF. The reason we want to put proper NAs here is that it may be hard to do analysis or do calculations on the rest of these numbers if we don't convert these to something that actually is a real NA missing value. So to do this here, this one's a little long because this column name is long, but remember I'm just adding on to my function. So I'm starting with opioid scrape. I'm cleaning the names up to make them a little bit easier to read. Taking out those totally empty rows. I am filtering for this row number 36 to remove that. And then lastly, I am taking the column called opioid involved overdose deaths. That's this big monster here. And I'm saying replace that with if you encounter an asterisk in this column, replace it with an NA. So what it's saying is overwrite this column. We're mutating the same name as the existing column name. If you see an asterisk in this column, put an NA here. That's what this NAIF function does. So now when we run this and look at it, we'll see this has, it's grayed out. It's a little bit hard to see, but it's grayed out. This is a proper, actually stored as a missing value in R. Okay. You may have noticed these column names are kind of unwieldy. They make it hard to read the code. We're going to use the rename function to clean that up a little bit. It's often not a bad idea to rename columns, especially if you're producing a document that will contain the intellectual foundation of your story, or provide a lot of evidence for the pattern that you found, to have things that people can understand and read. So I'm just going to use the rename function here to convert this very verbose opioid-involved overdose deaths, 100K persons 1 2017 to death rate, And then the rate of opioid prescriptions, I'm just going to call Rx rate. Okay, and we see that those have been renamed. Okay, so it's looking pretty clean. We're now hopefully at a point where we can actually work with this data. So I want to write a little bit of code here to approximate something we might do in the analysis. I just want to calculate the average prescription rates, opioids per person, for each state. So I'm going to take our opioid scrape working. This is the thing we've cleaned. And I'm going to summarize it. I'm not grouping, so I'm just calculating the overall average, creating a new column called mean Rx rate, setting it equal to the mean of the Rx rate column. And when I run that, I get an NA, which is not good. It means something's gone wrong. I mean, theoretically, these are all numbers. We should have been able to calculate the average. The code I've written here is correct. So I want to use the glimpse function to take a look at the data. The glimpse function, when you're cleaning data, can be really useful because it gives you a lot of information about how the data, each column is stored, what some example values are. And what do we see here? Well, we see a clue to what might be going wrong. First of all, these numbers are in quotes. Okay, if they were really just numbers, we wouldn't necessarily expect them to see them in quotes. Usually that's reserved for strings of characters or strings like the state name. We also see here that it says CHR. So what's happening here is both of these, even though they're actually numbers, death rate and Rx rate, they are stored as characters. And if we're going to actually do any kind of math to them, including computing the mean, then we are going to need to convert them to numbers. So I'm going back and I'm going to update my original cleaning function. So doing all the things we're doing before. Take an opioid scrape, cleaning up the names, removing the empty rows, getting rid of that NA row, on and on, until we get to the bottom here, where I'm saying Rx rate. When I mutate, set Rx rate equal to the Rx rate column, which right now is character, as numeric. Doing the same thing for death rate. So when I run that, and I glimpse it, I can see that these are all now stored as doubles. There are many, many different number formats. Double is one kind of number. What's important here is it is a number. There's no quotes around it. And when we do math on it, it works. The one thing the reason I did this, a point I want to make here with data cleaning is that sometimes people think there's there's we load the data part, and then there's the cleaning part, and then there's the analysis part. It's all very linear. In practice, that's not really the way it generally proceeds. Usually I'm loading data, I'm trying to do as much sort of standard data cleaning things that I know of before I get to the analysis. But there's almost always going to be things that I miss. There's also only things you're going to discover when you start doing certain kinds of analysis, certain flaws in the data. So even when you get to the analysis phase, you really want to have your brain attuned to like, oh, there's still maybe some hidden problems. And when you discover those problems, all you do is go back up to the top of your document where you're doing your data cleaning, add those fixes to your script, and then come back and do your analysis. It's the really nice part of working in these files. Okay, so I want to show you a couple more data cleaning things. And to do that, we're going to load in a new data set. This is a data set we actually used in last week's lab. This was lab 9. And it's got opioid death rates by county. So I'm going to go ahead and read this in. Let's take a look at it. And I'm just going to pop this out here. All right, so this data has a host of issues. You've got this like notes column on the left here. It's just full of NAs. Not really much point to it. It's got really messy column names with spaces and percent symbols, things that make it hard to manipulate potentially. Um, uh, we have a lot of data here. This is uh, these are columns that like the crude rate. This is the death rate from opioids in each county. Ostensibly it includes some. It's numeric, right? It's got 6.4 deaths for Baldwin County, Alabama. But it's mixed in with text, so it's going to be really hard to do math on this. Um, if we scroll all the way to the bottom, there's like a ton of NA columns that were just like extra and tacked on. There's this like totals row at the end, which contains averages, which if we're trying to, you know, take an average, say, for the whole country or for one state, the inclusion of this may throw off some things. So yeah, so a bunch of problems. We learned to fix most of these above. So I've just written a script here that includes some very basic cleaning things. So I'm just going to read this in again. But this time, I'm going to clean up the column names. I'm going to use the same string detect function here to filter out the one column we want to work with here is called age adjusted rate ultimately. So I'm just going to filter out any values that are suppressed or unreliable. There's one other too called missing. I'm just going to filter those out. So I'm saying filter and return everything that is not this, or the little pipe is or this is unreliable or suppressed or missing. I'm only going to keep the columns I need: county code, county deaths, and age adjusted rate. I'm going to convert the deaths column and the age adjusted rate to numeric so we can actually work with them. And then I'm using a different method to filter out all those blank rows at the bottom and the statewide or the nationwide total. And I'm just saying if there's an NA value in this county column, don't return it. So I'm going to go ahead and run that. And it's looking a little bit cleaner already. Okay. There's still a lot we can do with this sheet to make it easier to analyze later. I want to think about a scenario potentially where we wanted to join this to another data set for which there wasn't like a county code we could join it with. We really just wanted to join it like on the name of one of the counties. But the name in that other data set doesn't match this. This is kind of messy in that it's got both the county name and the state kind of mixed in. A tidier data set would actually separate these into two separate columns. So we can do this. So I'm just going to create a new copy of the thing I've read in here, opioids, deaths, county, working. And I'm going to use the separate function to split this county column into two separate columns, county and state. So I'm just going to run that. So we got county and state. And then I just want to break down what happened there. It basically said, take what was in this county column, put it into two columns, county and state. What are they separated by? The information we want to divide by a comma. Everything that was on this side of the comma, put in the county column. Everything on this side, put the state. Okay. Yeah, so that worked pretty well. The one problem we're running into here, if we look at it, is that let's pop it open and look at it here. If we highlight this, it's a little bit hard to see, but there's actually like an extra space on the other side of AL. So if I paste that in here, we can see how that's working. Yeah, it's got an extra tab, but there's basically one extra bit of white space there. So if we're trying to join this, say, to another table uh, on the state, we might run into problems. So there's a nice little thing we can use. It's part of the stringer package called the string trim function. So I'm just going to go ahead and run this. And I'll pop this open. And now there's not a little bit of white space. Um, that's really common. You'll see, you know, cells will have like an extra space on sort of either side. Um, and that can make it hard to join things, or when you're trying to filter things, if you miss the space, it can make it hard to work with. So this is a really good one, string trim, to have in your arsenal. The reason that happened, that space popped up, is when we use that separate function. If you notice here, we said split everything in this column into two. Everything on this side of the comma into the county column, everything on this side of the comma into the state column. And there's actually a little space there between the comma and the A. So that's why that space ended up there in the first place. Okay. So something else that maybe pops up when we're trying to join it to another table is that all of the county names in the other table are lowercase, and in this table they're not. And so in order for them to join properly, we would need to correct that. So there's a nice function called toLower, which does exactly what it sounds like. There's also a toUpper, and there are some others for doing like capital cases and title case. So I'm just going to add that to the end of my function. So right after string trim, I'm basically overwriting the county column by saying toLower county. What it does is, it was uppercase here, right? Had the capital letters there. It's removing all of them here. Okay. Then let's suppose we still need to do a little bit more work on this to be able to join it to our other table. And that is that the other table doesn't have the word county in it. It just has Baldwin or Blunt or Escambia. And if we want to join it, we need to get rid of county. Or in Louisiana, they call them, let's just pop this open here. Louisiana, they call them parishes, not county. Or in Alaska, they're called boroughs. There are some that are called boroughs. So if we want to take those out pretty consistently, we can add this string remove function. So what I'm saying here is, in the county column, overwrite it, and wherever you see the word county or parish or borough, remove it. So now when I run this, it's stripped off the word county. Okay. And if we wanted to, we could go back and string trim there, because there is a little bit of extra space there now. So why don't we throw that on there, actually. Equals string trim state. Oops. String trim county. And now that little space isn't there. So again, just sort of little things you want to think about. Okay. One little bit of thing before we get to your task for this assignment, which is I want you to think of a scenario where it would be useful to extract the state code from the 5-digit FIPS code. So this is a FIPS code. and it's composed of two separate parts. The first two digits are signifying which state. So this is 01, Maryland is 24. And then the last part is a three-digit signifier for that county within that state. So Baldwin is 03, Blount is 09. So let's suppose it would be useful uh, to be able to create a column that just had the state code in it. So I'm just going to add on to my code here, this little thing here. So I'm saying overwrite or create a new column called state code, which doesn't exist in our data, and use string sub, which is again a function from the stringer package, saying take the county code column, start with the first digit all the way at the left, and then end with the second digit all the way from the left. Then I'm just reorganizing things a little bit. I'm selecting the state code that we just created, so that's going to be first in our column, and then put everything in our data frame, and then put everything after that. So what do we end up with? It is pulled out the first two digits and put it in its own column called state code. Okay, so now it's time for your task. You're going to put together everything you've done or learned about in this lab into a practice of your own with some messy data. So I have provided for you a data frame of the rate of opioids prescribed to Medicare patients, mostly seniors, in Maryland. And I got that from the Center for Medicare and Medicaid Services. They have this nice mapping tool and data set showing rates of prescriptions to seniors, mostly under Medicare from 2013 to 2017. So could be useful to look at how senior prescribing rates compared with the country as a whole. So let's go ahead and read that in. And there are some obvious problems we'll talk about here. Okay, so hopefully you can pick out some of these by now. It's got some wordy column names with empty spaces. We can fix that. It's got a totally empty row that needs to be removed. It's got this row of statewide averages that if we were trying to compute things on our own might monkey things up a bit. Instead of having like a proper NA when it's missing data, it's a text string that says no value provided. So you're going to write a single long script function to fix those problems. You're also going to fix some of the other issues that are apparent here that keep this from being a truly tidy data set. So one thing I'd like you to do is break apart the county name, this county column here, which contains county and state, into two separate columns, one for the county, one for the state. I'd like you to fix the inconsistent capitalization in the newly created county-only column that you create so that everything's lowercase. Any extra white space that pops up, I want you to fix that. I also want you to create a new column called state code that strips off the first two digits from the FIPS code. When you're all finished, your data frame, I've got an example here, should look like this. Okay, nice and clean. And yeah, go ahead and put your code here. So when you're finished, you're going to knit and you are going to upload it, uh, the HTML and the knit markdown file to GitHub and submit on Elms. Okay, thanks very much.